AI is about how it's going to change the world and the global economy. Today, I want to talk about how AI can add to the world economy and how AI can increasingly become a foundational technology that everyone in this room can be utilizing, enhancing our lives, enhancing the lives of everyone in the world. And we need to talk about how it's going to reshape productivity, labor, infrastructure across virtually every other sector. But importantly, how it's going to reshape the world, and how can more segments of the world benefit from AI? And how can we ensure that we have a broadening of the global economy, not a narrowing of the global economy? And I can't think of another person who has a clearer view on not just what AI is, but the infrastructure around it, the infrastructure that is necessary to build around it. And because so many of the major hyperscalers are utilizers of what NVIDIA creates, and the whole engagement around the infrastructure around AI, the potential of AI, I think we have a great voice to listen to this afternoon or this morning. So Jensen, once again, thank you. This is his first time here at the World Economic Forum in Davos, and I know you have a really busy schedule, so thank you for taking that time.
I appreciate that.
So let me go right into it. Why do you believe that AI has the potential to be that significant engine of growth? And what makes this moment, this technology, different than past technology cycles?
Yeah, this is, first of all, when you think about AI and you're interacting with AI in all these different ways, ChatGPT, of course, using Gemini, of course, using Anthropic, Claude, of course, and the magical things that it could do, it's helpful to reason back to the first principles of fundamentally what is happening to the computing stack. This is a platform shift. A platform is something where applications are built on top of. And this is a platform shift like the platform shift to PCs. New applications were developed to run on a new type of computer. Platform shift to the internet, a new type of computing platform, hosted all kinds of new applications, a platform shift to mobile cloud. In each and every one of these platform shifts, the computing stack was reinvented and new applications were created. This is a new platform shift in the sense that today you're using ChatGPT. It's important to understand that itself is an application, but very importantly, new applications will be built on top of ChatGPT. New applications will be built on top of Anthropic Claude, for example. And so it's a platform shift in that way. AI is really easy to understand if you realize what it can do that you could never do before. Software in the past was effectively pre-recorded. Humans would type and describe the algorithm or the recipe for the computer to execute. It was able to process structured information, meaning you've got to put the name, the address, their account number, their age, where they live. You create these structured tables that software would then go and retrieve information from. We call it SQL queries. SQL is the single most important database engine the world's ever known. Almost everything ran on SQL before now. Now we have a computer that can understand unstructured information, meaning it can look at an image and understand it. It could look at text and understand it. It's completely unstructured. It could listen to sound and understand it, understand the meaning of it, understand the structure of it, and reason about what to do about it. And so for the first time, we now have a computer that is not pre-recorded, but it's processed in real time, meaning that it's able to take the context of the circumstance, whatever the environmental information, the contextual information, and whatever information you give it, it could reason about what is the meaning of that information and reason about your intent, which could be described in a really unstructured way. You describe it however you want to describe it. We call it prompts. But you describe it however you like to describe it, and to the extent that it can understand your intention, it could perform a task for you. Now, the important thing about this is that because we're reinventing that entire computing stack, the question is, what is AI? You're asked, when you think about AI, you think about the AI models. But it's really important to understand industrially, AI is actually essentially a 5-layer cake. At the bottom is energy. AI, because it's processed in real time and it generates intelligence in real time, it needs energy to do so. Energy is the first layer. The second layer is the layer that I live in. It's chips and computing infrastructure. The next layer above it is the cloud infrastructure, the cloud services. The layer above that is the AI models. This is where most people think AI is. But don't forget that in order for those models to happen, you have to have all of the layers underneath it. But the most important layer, and this is the layer that's happening right now, the reason why last year was an incredible year, frankly, for AI, is that the AI models made so much progress that the layer above it, which is ultimately the layer that we all need to succeed, the application layer above that. And so this application layer could be in financial services, it could be in healthcare, it could be in manufacturing. This layer on top ultimately is where economic benefit will happen. But the important thing, though, because this computing platform requires all of the layers underneath it, it has started, and you guys everybody's seeing it right now, it has started the largest infrastructure build-out in human history. We're now a few $100 billion into it. We're a few $100 billion into it. Larry and I, we get the opportunity to work on many projects together. There are trillions of dollars of infrastructure that needs to be built out, and it's sensible. It's sensible because all of these contexts have to be processed so that the AI, so that the models can generate the intelligence necessary to power the applications that ultimately sit on top. And so when you go back and when you reason about it layer by layer by layer, and you realize that the energy sector is now seeing extraordinary growth. The chip sector, TSMC just announced they're going to build 20 new chip plants. Foxconn working with us, and Wistron and Quanta building 30 new computer plants, which then go into these AI factories. So we have chip factories, computer factories, and AI factories all being built around the world. And remember, right, exactly, those chip fabs. Micron has started investing $200 billion in the United States. SK Hynix is doing incredibly. Samsung is doing incredibly. You could see that entire chip layer growing incredibly today. And now, of course, we pay a lot of attention to the model layer, but it's really exciting that the layer above them is really doing fantastically. And now, one indicator is where the VC funding going into. Last year, 2025, was one of the largest years in VC funding ever. And last year, most of the funding went to what is called AI native companies. These are companies in healthcare, they're company in robotics, and company in manufacturing, financial services. All of the large industries in the world, you're seeing huge investments going in to those AI natives because for the first time, the models are good enough to build on top of.
So let's just dive a little further. Obviously, everybody, I'm sure, uses their own chatbot and getting information. So, but you're talking about the dispersion of AI is going to be the key. Let's talk about it, like, go into a little more upside ideas related to the dispersion of it in the physical world. You mentioned, obviously, healthcare is a great example of that. But where do you see the transformational opportunities in areas like transportation or science?
Well, last year, I would say last year, I would say 3 major things happened in AI, in the AI technology layer, the model layer. The first one is that the models themselves started out being curious and interesting, but they hallucinated a great deal. And last year, we can all reasonably accept that these models are better grounded. They could do research. They can reason about circumstances that maybe they weren't trained on, break it down into step-by-step reasoning steps and come up with a plan to answer your question, do your research, or perform the task. So last year, we saw the evolution of language models becoming AI systems that we call agentic systems, agentic AI. The second major breakthrough is the breakthrough of open models. Several years ago, was it a year ago, DeepSeek came out?
Last year.
And DeepSeek was, a lot of people were quite concerned about it. Frankly, DeepSeek was a huge event for most of the industries, most of the companies around the world, because it's the world's first open reasoning model. Since then, a whole bunch of open reasoning models have emerged, and open models has enabled companies and industries, researchers, educators, universities, startups, to be able to use these open models to start something and create something that's domain-specific or specialized for their needs. The third area that had enormous progress last year was the concept of physical intelligence, of physical AI. AI that understands not just language, but AI understands, if you will, nature. And it could be AI that understands the physical world here, AIs that understand proteins, chemicals, natural physics, for example, fluid dynamics, particle physics, quantum physics, AIs that are now learning all these different structures and different languages, if you will. Proteins is essentially a language. And so all of these AIs are now making such enormous progress that these industries, industrial companies, whether it's manufacturing or drug discovery, are really making great progress. And one of the great indicators is a partnership that we had with Lilly, that they realize now that AI has made such extraordinary progress in understanding the structure of proteins and the structure of chemicals, essentially being able to interact and talk to the proteins like we talk to ChatGPT. We're going to see some really big breakthroughs.